Welcome to this video lesson, which is the full solution to the practice questions from lesson 9 of vectors. In the first question, we're asked to show that points A, B, and C are collinear. If points are collinear, that means that they lie in the same line. So imagine we got a line here and we got points A, B, C. And the order here doesn't matter. It could be B, A, C, or C, B, A. For these points to be collinear or lie in the same line, if we were to write these as vectors, let's say we wrote it as vectors A, B, and B, C, because they're going in the same direction or opposite direction, again, it doesn't really matter. That's one of the things we need to prove. So if they're going in the same or opposite direction, they are parallel. And for that to happen, vector AB needs to be a scalar multiplication of vector BC. And this is to prove that they're parallel. Well, the other factor that's really important for things to be in the same line is that they need to share one of the points, because if they're parallel, that means AB could be here and BC could be here. But since it's AB and BC and they both share the same point, that means they're also on the same line. This would be the same thing if we had chosen AC and CB, because if they're parallel, they're going in the same direction or opposite direction, and if then they would both share point C. And we could do the same thing where they share point A as well. Okay, so this point B share point B. And you don't always have to write this, you just need to write this portion of it. Okay, let's find vector AB. We are going to take the x, y, and z values of point B. Those are 6, 4, and negative 16. And we're going to subtract them by the x, y, and z values of point A. So those are 33, negative 5, and 20. And when we do those, we get 27, negative 27, 9, and negative 36. Let's find vector BC as well. So I will take all the x, y, and z values of point C. So we get 9, 3, and negative 12. And we are going to subtract them by the x and y and z values of point B. So those are 6, 4, and negative 16. When we do this, 9 minus 6 is 3, 3 minus 4 is negative 1, and negative 12 minus negative 16 is negative 12 plus 16, which will be 4. Now, our next question is AB scalar multiplication of vector BC? So AB is negative 27, 9, and negative 36, and we want that to equal to K. BC is 3, negative 1, and 4. Well, this means we're going to have to compare their x components, their y components, and the z components. So on the left hand side, I got for the x component, I got negative 27 is equal to, right hand side is 3 times k, so that's 3k. And then I have 9 is equal to negative k. And then I have negative 36 is equal to 4k. Solving all of these for this first one, divide both sides by 3 and I get k is equal to 9. For the second one, divide both sides or multiply both sides by negative 1, I get k is equal to negative 9. And for the last one, divide both sides by 4 and I get k is equal to negative 9. So consistently, k is equal to negative 9. And since AB is equal to negative 9 times vector BC, therefore the points are collinear. In this question, we're told that point B is 3 units from point A, and we're given the direction in which it is away. Okay, fantastic. We want to determine vectors AB, vector OB, O always originates from 0, 0, and finally the coordinates of point B. Now this one is a little confusing if you don't draw it out. So let's draw it out first. We got point B, which is 3 units from point A. So I'm going to draw a coordinate system, and point A is approximately 4, negative 3. So let's say this is point A, and 4, negative 3, and I'm just sketching everything. And that point B is in the direction negative 2, so that's negative 2 and 1. So it's in this direction, and it's 3 units away. Now this is the challenging part, because we don't actually know if each unit is this long or each unit is maybe longer, bringing the point here, or they could be very long. So that's kind of the whole challenge of doing this question. So the information that we do have is, first of all, that A has a coordinate of 4 and negative 3. We know that it's going to go 3 unit vectors away from that, and it's going to reach some point B. And again, I don't know if B is here or somewhere else. I'm just going to assume that it's here for now, calculate everything, and then we can change the location later. This is just a sketch. So we know the direction of this vector that we want is negative 2 and 1. So that's the direction. So we can find a unit vector in that direction. So unit vector will equal to, let's call this vector W, and the unit vector of W is going to be W divided by the magnitude of W. So this is going to equal to, well, first we need the magnitude of W. So to do that, we are going to take the square root of the x component squared plus the y component squared, and that will give us root 4 plus 1, which is root 5. Once we have this, this is going to equal to 1 over root 5 multiplied by the x component of vector W and the y component. So once again, I'm just going to color code everything so you can see things a little bit better. This is 1 over root 5, and this is my vector W. Now, this vector over here, I'm going to call that unit vector W. I'm going to give it the hat. This hat often means unit vector. And once I have this, I know that vector AB is equal to 3 times unit vector W. And once I have that, I know that this is 3 times 1 over root 5 multiplied by the x component and y component of the vector. And this will end up being 3 over root 5 negative 2, 1. Or you can also rationalize the denominator and write this as 3 root 5 over 5 negative 2 and 1. Okay, the next part of the question is asking us to find or determine vector OB originating from the origin and going to point B, and C to just find the coordinates of B. There is a way to find OB without finding coordinates of B first, but it's a lot easier to find coordinates of B first. So let's do that first. Okay, vector AB is going to equal to the x and y coordinates of point B minus the x and y coordinates of point A, which are 4 and negative 3. And that's going to equal to 3 root 5 over 5 of negative 2 and 1. And we can now use an equation for the top and the equation for the bottom, or the x and y components. So for the x component, I get xb minus 4 is equal to 3 times negative 2 is negative 6 root 5 over 5. And for the y component, I get yb minus negative 3, in this case is plus 3, is going to equal to 3 root 5 over 5 times 1, which just stays the same. I am going to add 4 to both sides for this, and I will end up getting the x component is equal to negative 6 root 5 over 5 plus, for 4 I can write it as 20 over 5, and that's going to equal to 20 minus 6 root 5 over 5 as my x coordinates. For the y component, I have to subtract 3 from both sides to isolate for the y coordinate. So this is going to be 3 root 5 over 5. And I'm going to subtract. The 3, I can write it as 15 over 5. So this is just 3. And I will end up getting 3 root 5 minus 15 over 5 as my y coordinate. So the coordinates of b will be 20 minus 6 root 5 over 5 and 3 root 5 minus 15 over 5. Back to part B of the question, I'll just do that very quickly here. For part B, OB, this vector over here is going to equal to the x and y, so I'll write it like this, coordinates of B minus x and y coordinate of O, which is the origin. So in this case, there's 0, 0. So it's just going to be x, b, y, b. And we have the x component as 20 minus 6 root 5 over 5. And for the y component, we have it as 3 root 5 minus 15 over 5. I did skip over the steps for this question on how to rationalize. So in this case, from here to here, all I've done is I've multiplied the numerator by root 5 and the denominator by root 5. Root 5 times root 5 gave me the 5, which is the 5 here, and the numerator stayed as 3 root 5. And the reason why we do that is because with roots, or sometimes radicals or surds, we don't want, the standard form for this is a root b over c, and we never want to have our denominator as a root, and that's the main reason why we rationalize. Okay, in this question we're asked to determine the values of x and y if the points a, b, and c are collinear. So just like the very first question, this means that all the points lie on the same line. So let's call it a, b, and c. And for the points to be collinear, vector AB, and we could have chosen other vectors as well. We're just going to use AB. It's going to be scalar multiplication of vector BC. Okay, so vector AB here is going to be the x, y, and z coordinate of point B, 3, 4, and 5. I'm going to subtract them by the x, y, and z coordinates of point A, which is 0, negative 1, and 1. When I do that, I get 3. 4 minus negative 1 is 5, and 5 minus 1 is 4. vector BC is going to equal to the x, y, and z coordinates of point C. Those are x, y, and 3. And I'm going to subtract them by x, y, and z coordinates of point B, which are 3, 4, and 5. This is going to equal to x minus 3, y minus 4, and negative 2. We know that for the points to be collinear, that means that vector 3, 5, 4, that's vector AB, is going to equal to some scalar multiplication of x minus 3, y minus 4, and negative 2, which is vector BC. To solve this, I need to break it down to the x, y, and z components. So for the x component, I have 3 is equal to k multiplied by x minus 3. For the y component, I have 5 is equal to k multiplied by y minus 4. And for the z component, for the last one, I have 4 is equal to k multiplied by negative 2. Basically, for them to be collinear, k has to be the same value for all the 3 cases. So I'm going to take this last case over here. 4 is equal to negative 2k. Divide both sides by negative 2 to get k is equal to 4 divided by negative 2, which is just negative 2. Once I have this, I can plug it back into these two equations. So I will have 3 is equal to negative 2 times x minus 3. And for the next one, I will have 5 is equal to negative 2 times y minus 4. For the first one here, I will get 3 is equal to, I'm going to expand, I'm going to get negative 2x, negative 2 times negative 3 is going to be plus 6. So then I will get negative 2x is equal to, I'm going to subtract 6 from both sides to get negative 3, and I will get x is equal to, divide both sides by negative 2 to get 3 over 2. And that's my x value. And for my y value, I'm going to use this equation. So 5 is equal to, I'm going to expand, so I'm going to get negative 2y, and negative 2 times negative 4 is plus 8, and I will get negative 2y is equal to, I'm going to subtract 8 from both sides to get negative 3, and then I'm going to divide both sides by negative 2 to get y value to also equal to 3 over 2. Note that this question could have also been done in this exact same way if we had chosen to use a vector AB is equal to a scalar multiplication of vector AC. In this case, point A would be shared. In this case, point B is being shared. And we could have also used vector BC is equal to vector AC or CA, it doesn't really matter. And then in this case, point C would have been shared. And in all of the situation, you would have gotten the y value and the x values to be the same thing. However, your k values might have been different. I hope that this video was helpful for you folks, and thank you for watching.